So good evening, welcome to Sakala Vidya YouTube channel. Okay, today we shall discuss now mensuration, multiple choice questions on mensuration chapter. Okay, welcome Uttam Chess, happy evening, Bollam Jaya, Pavitra, next Vijay Kumar, Chinni, right, Soni, welcome, Lakshmi, Allah Basha, right. Right, let us start the class now today session. Good evening all, good evening, good evening, good evening. Vandana, welcome. Right, happy evening. Riyaz Basha. 14th question. 14th question. The circumference of the edge of a hemispherical bowl is 132 centimeters. The capacity of the bowl is in centimeter cube. First option 2772. Option B 924. Option C 19404. Option D 9702. Right. I am studying into first year. Okay, no problem. The circumference of the edge of a hemispherical bowl is 132 centimeters. Then the capacity of the bowl. Capacity means you remember volume. Capacity means we need to find out value. So volume of a hemispherical bowl we need to find out. So that means actually let us draw the figure. This is the hemispherical bowl. This is called edge. This is the circle. Say this radius is r. But what is given actually? Circumference. So circumference means perimeter of. So this perimeter of this circle is given 132. So that means we can find out like this. So this is nothing but 2 pi r. 2 pi r equals to 132. So this we can write 2 into 22 by 7 into r equal to 132. Now r equal to 132 multiplied by 7 upon 2 times 22. 11 2 ja, 11 1 ja 11, 11 2 ja. So that means 12 into 7 by 4. 4 into 3, 21. So that means radius is 21 centimeter. Now what we need to find out actually here? So we need to find out the capacity or volume of the hemisphere whose base radius is 21 centimeters. So that means volume V is equal to 2/3 of pi r cube. So that is equal to 2 by 3 into pi means 22 by 7 into r cube. R cube means, see, r value is 21. That 21 into 21 into 21 we can write. 7 1 ja, 7 3 ja. 3 1 ja, 3. Cancel. 22 into 2 is 44. 21 into 21, 21 square. 21 to 21 is equal to how much? 21 into 21. 21, 441. Now 441 multiplied by 44. 4 1 ja 4, 4 4 ja 16. 4 4 ja 16 plus 1, 17. This is 4, this is 6, 7, 1. 4, 10, 14, 9. So 19,404 centimeter cube. This is the answer. So option C is the right option. Option C is the right option. Yes, Pavitra, absolutely correct. Absolutely correct. 15th question. 15th question. If the volume of a cube is 1728 centimeter cube, the length of edge means regarding to the cube, that is the side, is equal to option A 7 centimeter, option B is 12 centimeter, option C is 18 centimeter, option D 19 centimeter. So this is the question. Okay. Uttam, very good. The volume of a cube is given that 1728 centimeter cube. Then the length of edge of the cube is equal to. So length of the side we need to find out. So Pushya, Vallika, right. So that means solution, volume V is equal to 1728 given. Volume of cube is a cube, side cube, is equal to 1728. This 1728 is nothing but 12 cube. So therefore A equals to side is equal to 12. Now we need to find out edge. Therefore side or edge both are same, equal to 12 centimeter. This is the answer. Or cubing the options also you will get the answer. 7 cube is 343, 12 cube is 728. So B is the right answer. By observing the options also we can say. So what is the volume of the cube? If the side is A cube. So go on cubing the options, which is equal to 1728. That will be the answer. So 1728 is the perfect cubic number. That is 12 cube. So 12 is the side. 12 is the side. 16th problem. 16th problem. A toy is in the form of a right circular cylinder surmounted by a right circular cone, as shown in the figure, if AD equals to DE equals to EC equals to 1 centimeter. The volume of the tie in centimeter cube is, right, first option 4/3 pi, B 3/4 pi, C 3 pi, D 4 pi. So let me give the figure. Figure is like this. This is the cylinder and a top cone is there. Okay, now what is given actually is C. Right. This is A, B, C, D and E. Okay, what is given actually? AD. AD means actually AD is equal to DE is equal to EC. EC is equal to 1 centimeter. Not EC, this will be DC. DC is equal to 1 centimeter. Okay, now what we need to find out means actually see dimensions first we need to find out. So base radius will be obviously actually equal to AD equal to 1 centimeter means R is equal to 1 centimeter. It's common to the both figures, cone as well as cylinder. So next height of the cylinder is, that is 1 centimeter, say capital H. Small h, height of the cone is also 1 centimeter. So now how to find out the value of the tie? Volume of the tie is equal to volume of the cylinder plus volume of the cone. So volume of the tie equals to volume of cylinder plus volume of cone. So volume of cylinder is equal to, what is the formula? Pi r square h plus volume of the cone is equal to, say this is capital H, 1/3 pi r square h. Substituting, see, so both heights are so equal, radii also equal. So that means what you get now here, pi into 1 square pi plus pi/3, r square also 1, h is also 1, 3 pi plus pi upon 3. 4 pi by 3 is the answer. 4 pi by 3. Yes. So A is the right option. A is the right option. Okay, 17th problem. 17th problem. Right, 17th problem. The surface areas of the two spheres are in the ratio 1:2. The ratio of their volumes is A √2:1, B 1:2√2, C 1:8, D 1:4. 1:4. Okay, let us check it now. See, the surface areas of the two spheres are in the ratio 1:2. Then the ratio of their volumes we need to find out. Here two spheres related formula. See, first say V1 is equal to 4 by 3 pi r cube, write down. This is first. Here V2 equals to 4 by 3 pi capital R cube. Now what is given actually here? What is given? Surface areas S1 by S2. Surface areas of a sphere means 4 pi r square upon 4 pi capital R square. This is equal to 1 upon 2. 4 pi gets cancelled. So r square by capital R square is equal to 1 by 2. Small r by capital R is equal to square root of 1 upon 2. That will be 1 by √2. So now what we need to find out means the ratio between these two we need to find out. So ratio between these two, V1 by V2 find out. V1 by V2 means this gets cancelled. So we get R cube by capital R cube. This we can write small r by capital R whole cube. This is 1 by √2 whole cube. 1 by √2 whole cube means 1 cube is 1, √2 whole cube means √2 into √2 into √2. √2 into √2, 2, so 2√2. This will be 2√2. So V1 is to V2 is equal to required ratio 1 is to 2√2. Okay, understood? Not 1:8, 1 is to √2. So B is the right answer. So you can check it now. All of you check your answers. Not C. B is the right option. B is the right option. So 18th question. 18th one. If the, this is very important, if the area of three adjacent faces of a cuboid are capital X comma capital Y and capital Z respectively. Then the volume of the cuboid is this is very important problem, very important problem, expected question for NTSC, all other entrance examination, even DSC, District Selection Commission, NDA or Air Force, even sometimes even SSC CGL examination too. It's very important problem. Okay, right. First option, let us write XYZ. Option B, 3 times XYZ. Option C, root over XYZ. Option D, root of 3XYZ. See, the area of the three adjacent faces of a cuboid are X, Y, Z. Then the volume of the cuboid in terms of capital X, capital Y, capital Z we need to find out. Okay, let's have a discussion on this one. So 18th problem. First let me draw the figure, cuboid figure. So this cuboid, let us draw the cuboid figure. Then you will get some idea. Okay. Let us say this is the length of the cuboid L, breadth B, this will be the height. This is a cuboid. Here adjacent faces means actually, so you take different color. The area of this red color face is given, that means area of this rectangle given. Take another color, green color. For example, next area of this rectangle given, take another color, area of this one given. So that means area of this red is L into H. So that means LH equal to capital X, equation 1. Area of one face. Area of the green face means here B into H. So BH is equal to capital Y. This is second one. So next area of this area we need to find out. So this area is rectangle, L length into breadth. That is LB equals to Z given. Now volume we need to find out. First multiply 1 and 2 and 3. That means X into Y into Z is equal to LH into BH into LB you will be getting. This is nothing but L square, next B square, next H square. Taking square root. See LBH equal to square root of XYZ. See L into B into H is nothing but volume of a cuboid. This is V. So V is nothing but root of X comma Y comma Z. So this is the answer. This is the answer. So that means C is the right option. C is the right option. You can check the solution. It's very important problem. Nineteen. a cylinder, a cone and a hemisphere are of equal base. Equal base means equal base radius, and have same height. The ratio of their volumes is, first option 3:1:2, option B 3:2:1, option C 1:2:3, option D 1:3:2. So Nikhil, this is also important problem. Cylinder, cone, hemisphere. The problem related to the 3D figures. Cylinder, cone, hemisphere of equal base. They have the same radius. Say R, base radius, and the same height. The height of the cylinder, height of the hemisphere. First you take the height of the hemisphere. What is the height of the hemisphere means? For example, radius is R. This is the height of the hemisphere. This will be R. Height of the hemisphere will be 2R, diameter. That means the height of the cylinder also 2R. See, radius is equal to R and height h is equal to 2R. Here for this one, radius is equal to R and h is equal to 2R. Here only one radius, though is three-dimensional, the parameter is only R for hemisphere. So what we need to find out? The ratio of their values. So V1 equals to volume of a cylinder. Volume of a cylinder is pi r square h. So pi r square into h means 2r. This is 2 pi r cube. This is V1. Next go to V2. Cone. Cone is what? 1/3 of pi r square h. Here h is 2r. This will be 1/3 pi r square into 2r. This is 2/3 pi r cube. Now V3. Volume of the hemisphere, that is 4/3 of pi r cube. This is standard formula. Then you find out the ratio. We need to find out what is the ratio. V1 is to V2 is to V3. So let us go back. V1 2 pi r cube is to, this is 2/3 pi r cube. So this is, what do you get now? 4/3 pi r cube. 4/3 pi r cube. So pi r cube is common in all. Pi r cube cancel. So now what do you get now here? 2 1 ja, 2 1 ja, 2 2 ja. So we get 1/3 is to 2/3. So multiply with 3. Because it's a fraction, you need to make integer. Multiply with 3. 3 1 ja 3 is to 3 into 1/3. 3 is to 1. 3 is to 1 is to 2 is the answer. 3 is to 1 is to 2 is the answer. 3 is to 1 is to 2. A is the right option. Yes, option A. problem number 20. Problem number 20. Go back. Yes. Hemisphere. Hemisphere is hemisphere is small change. Wait now. Yes, I did mistake. Yes, exactly correct. Yes, I need to rectify. Hemisphere 2 by 3 4 pi r cube. Okay, 2 by 3 4 pi r cube. So that means what do you get now here? 2 by 3. 2 by 3 is also 1 by 3. 3 is to 1 is to 1. 3 is to 1 is to 1 is not given. Just you change it. Option A. Now 20th. The ratio of the volume of a cube that of the sphere which will exactly fit inside of the cube is option A 6 is to pi, option B 4 is to pi, option C 2 is to pi, option D 3 is to pi. Right. See, the ratio of the volume of a cube that of the sphere, volume of the sphere, which will exactly inscribed or fit inside of the cube. So that means actually a sphere is inscribed, 1 minute, exactly inscribed like this. Inscribed in a cube. Okay. So now first let us say like this. Let us say let A be the side of a cube. Let A be the side of a cube. This is the side of the cube. Now this becomes actually diameter of the, let A be the side of the cube, then volume of the cube you can find out, V is equal to A cube. So now leave it. Now this becomes actually, A becomes diameter, D is equal to A. Now the radius R will be half of D by 2. So R is equal to, A by 2. R will be A by 2. Now the volume of the sphere V2 is equal to 4 by 3 pi r cube. Pi r cube means A by 2 whole cube. This is, you will be getting like this, 4 by 3 pi into A cube upon 2 cube is 8. 4 1 ja, 4 2 ja. This is 1 by 6 pi a cube. The ratio between this a cube and this 1 by 6th pi of a cube we need to find out. So that means actually, so now V1 is to V2. V1 is to V2. That is a cube is to 1 by 6 pi a cube. A cube 1 ja, a cube cancel. We have 1 is to pi by 6. So multiply with 6. Multiply with 6 on both sides. So we get like this. 6 into 1 is to 6 multiplied by pi by 6. 6 1 ja 6 cancel. 6 is to pi is the required ratio. 6 is to pi. So A is the right option. A is the right option. Okay, Nikhil, I will give the timings. Don't worry. So one day, generally, 2 classes I will take, because actually on November 28th you have the examination for IIIT. So just in general, usually I take 2 times daily classes. So but generally 1 class may be there besides regular classes. So this is the 20th problem. Now let us move to the 21st problem. So let us move towards to the 21st problem now. Yes. The volume of a vessel, in the form of a right circular cylinder is 448 pi centimeter cube. That means volume of the cylinder is given. Okay. So in general 432, evening 432 class, right? Now 448 pi centimeter cube, and its height is 7 centimeters. So that means height of the cylinder is given. The radius of the base, radius we need to find out, is A 4 centimeters, B 6 centimeters, C 8 centimeters, D 2 centimeters. This is the question. So now all of you just read the question very carefully. The volume of the vessel in the form of a right circular cylinder is 448 pi centimeter cube. The volume of the cylinder is given, and whose height is 7 centimeters. Now we need to find out the missing parameter, that is the radius, base radius. Smaller we need to find out. Okay. So that means actually what is given and what is we need to find out. Volume of the cylinder V given, that is 448 pi centimeter cube, and height given h is equal to 7 centimeters, and we need to find out R value is question mark. Problem is related to the cylinder. What is the volume of the cylinder? Yes, that's correct. Pi r square h equal to 448 pi. This pi gets cancelled. So let us substitute here r square. R h is 7. 7r square equals to 448. Now r square equals to 448 upon 7. So 7 7 6 ja 42, 44 minus 42 28, 7 4 ja 64. R equals to square root of 64. So you can expect it. What is the square root of 68? That is 8 centimeters. So C is the right option. Yes, absolutely correct. Absolutely correct. So you need to continue till the completion of the session. Understood now? Okay, 22. 22. Right, 22. A cone and a hemisphere have equal bases and equal values the ratio of their heights is A 2:1, B 3:1, C 4:1, D 1:1. That means heights are equal, 1:1. Okay. See, cone, hemisphere have equal bases. Equal bases means they have the equal radii and equal values. Their values also equal. So let us draw the figure now. First, this is a cone. Okay. This is the height of the cone. Say H, base radius is R. So this is the hemisphere. So whose base radius is R and height will be this one. Height also same, R. Height is R. So now the ratio between the height, this height, H is to R, we need to find out the question mark. This is the problem. So what is given actually? Equal values given. So solution. So volume of the cone is say V1. Volume of the hemisphere say V2. V1 equals to V2 given. What is the volume of the cone? That is 1/3 of pi r square H equal to volume of the hemisphere 2/3 of pi r cube. Am I correct? So that means pi gets cancelled, 3 gets cancelled. We have r square H equal to 2r cube. Bring r cube this side. R square H by r cube equal to 2. So this can be written, r square means you get r, H by r equal to 2/1. So H is to R is 2:1. So this is the answer. Okay. So one problem actually I did mistake this problem. This can be rectified now. So this can be rectified, this problem. So let us rectify it. Because now I got an idea. Sorry, this problem is I did wrong. Now I will correct it. Okay, let me read the question once again. This question. So please note down all of you once again. Let us do this problem. 19th problem. Here cylinder, cone, hemisphere have equal base and same height. So let us say volume V1, this is V2, this is V3. So V1 is to, V2 is to, V3 you need to find out. Volume of the cylinder is actually pi r square h is to volume of the cone is 1/3 of pi r square h is to volume of the hemisphere is 2/3 pi r cube. Here it's clear that this hemisphere, height of the hemisphere also h is equal to r, same height. In the place of h, r substitute. Pi r square into r, pi r cube is to 1/3 of pi r cube is to 2/3 of pi r cube. Now see the pi r cube 1 ja, pi r cube cancel. So we have 1 is to 1/3 is to 2/3. Multiply with 3. So this equal to 3 is to 1 is to 2. 3 is to 1 is to 2. So A is the right option. A is the right option. Please all of you change your solution, 19th solution, because not sphere, hemisphere is given. Hemisphere means height of the hemisphere also small r only. If the sphere is given, then height becomes 2r, diameter, you remember. Instead of hemisphere, if the sphere is given, the previous method was correct. Now the previous method was wrong, so this is the correct way. Sorry, absolutely sorry. So you need to change your answer like this. Okay, right. Noted. Shall I move to next problem? Shall I move to next problem? Okay, 23rd problem. 23rd problem. 23rd. The base radii of two right circular cones of same height or in the ratio 3:5. The ratio of their volumes is option A 3:5, option B 5:3, option C 9:25, D is 27:125. I think D will be the answer. You can check. The base radii of two right circular cones of same height. They have the same height. The ratio of the base radii are in the ratio 3:5. Then ratio of their volumes we need to find out. So that means actually what is given here, same height. First V1, volume of the first cone. So we can write 1/3 pi r1 square h, same height. V2 1/3 pi r2 square. They are different radii, height is same. So what is given? 3:5. R1 is to R2 is equal to 3:5. So R1 upon R2 is equal to 3/5. If you cube it, you will get the answer. Yes, D is the right option. So now we need to find out V1 upon V2. V1 upon V2 means, you see, so this and this will be gets cancelled. V1 by V2 is equal to R1 square by R2 square. R1 square by R2 square. Sorry, square you will be getting, not a cube. H will be gets cancelled, same height. So this is R1 upon R2 whole square. This is 3/5 whole square. So you get 9 upon 25. So V1 is to V2 is equal to 9 is to 25. Sorry, C is the right option. C is the right option. Yes. Right. So 24th problem. 24th problem. The ratio of the volumes of two cones is 4:5. That means ratio between the volumes of two cones is 4:5, and the ratio of their radii or ADII radii is 2:3. The ratio of their vertical heights is A 4:5, B 9:5, C 3:5, D 2:5. First read the question carefully and try to solve it. So the problem is related to the cone, means the volume of the cone is 1/3 of pi r square h. Here we have the two different cones. Radii are different and actually heights also different. So that means first of all write down solution. V1 is the volume of the first cone, that is 1/3 of pi is constant. R1 square H1 write down. V2 is 1/3 of pi R2 square H2. Why should I write like this? Because both are the cones only. Both are the cones itself only. And what is given? This is nothing but ratio of the volumes. That means V1 is to V2 given. That is 4:5. And what is given? Ratio of their radii also given. That is R1 is to R2 is equal to 2:3 given. And ratio between H1 and H2 we need to find out. So that means write down V1 upon V2 write down. V1 upon V2 means what happens now? This 1/3 of pi gets cancelled. We get R1 square upon R2 square into H1 upon H2 you will be getting. Let us substitute the values. See, V1 by V2 is equal to 4 upon 5. R1 by R2 is, this is R1 by R2 is equal to 2/3. This is 2/3 whole square into H1 by H2. Okay. 4 by 5 equals to 2 by 3 whole square into h1 upon h2. This is equal to 4 by 9 into h1 by h2. So now h1 by h2 is equal to, you can write 4 upon 5 into, this reverses, 9 upon 4. 4 cancel, 4 1 ja, 9 upon 5. So the ratio between the vertical heights h1 is to h2 is equal to 9 is to 5. 9 is to 5. Yes, B is the right option. B is the right option. So any new viewers are there, please do subscribe, like, subscribe and share. Okay, 25th problem. 25th problem. If the diameter of a sphere is d, diameter of a sphere is given is d, then its volume is, what is its volume? That means volume in terms of d we need to find out. Option A, 1/3 of pi d cube. B, 1 upon 24 of pi d cube. C, 4 by 3 pi d cube. D is 1/6 of pi d cube. So even though in the mensuration chapter, as far as three-dimensional figures is concerned, whenever diameter is given, you remember you need to find out radius. After that we need to find out, first we find the circumference. No, we need not find out the circumference. Directly find out the radius small r will be d by 2. Substitute in the formula, we get the answer Vijay Kumar. Okay. So the diameter of the sphere is d, so that's why obviously r equal to d by 2. So volume of the sphere is given by V is equal to 4 by 3 pi r cube. Substituting 4 by 3 pi r cube means d by 2 whole cube. So make it simplify. 4 by 3 pi times d cube upon 2 cube is 8. 4 1 ja, 4 2 ja. So this we get like this. 1 by 3 into 2. 1 3 into 2 6. 1 by 6 pi d cube. This is the answer. So all of you check it now. You can check yourself. This is actually pi d cube by 6. Pi d cube by 6. This can be written 1 by 6th of pi d cube. Yes, D is the right option. D is the right option. Twenty-sixth problem. The length of the longest rod that can be placed exactly, or that can be fit exactly in a cube of side 10 centimeters is option A 20 centimeters, option B 25 centimeters, option C 20 root 2 centimeters, option D 10 root 3 centimeters. 10 root 3 centimeters. This is very important question. So very important question. The length of the longest rod that can be placed exactly in a cube of a side 10 centimeters. Of a side 10 centimeters. See, this is the cube. First you take the cube. So let us draw the cube. Okay. So whose side is given? This side 10 centimeters. So now take the red color here to here. This is the diagonal. This longest rod, length of the longest rod. This length you need to find out. This length, diagonal, that's also called the length of the longest rod is diagonal of the cube. Diagonal of the cube. So length of the longest rod equal to diagonal of a cube. Diagonal of a cube is given by root 3 times A. Here side A is equal to 10 centimeters. So that's why 10 root 3 centimeters. This is the answer. So D is the right answer. D is the right answer. D is the right answer. 27th. The length of the diagonal of a cube whose side is 10 root 3 centimeters is A 30 centimeters, B 30 root 3 centimeters, C 10 root 3 centimeters, D 32 centimeters. The length of the diagonal. The length of the diagonal of a cube. Sorry, not cube. That is a cube. Sorry. The length of the diagonal of a cube whose side is 10 root 3 centimeters is. So we have the formula already given. Solution. Here let side of the cube A is equal to 10 root 3 centimeters. Length of the diagonal. Length of the diagonal is given by the formula, that is root 3 times A. So root 3 into 10 root 3. Root 3 into 10 root 3. Yes, let us try. So now root 3 into root 3. See, root 3 into root 3 is equal to, you get 3. So this equals to 10 times 3. Obviously 30. 30 centimeters is the answer. So A is the right option. A is the right option. A is the right option. Yes. 28. The length of the longest rod that can be exactly placed in a cuboid, not cube, this time cuboid. Shanmukh or from Sri Chaitanya College. Welcome Shanmukh. In a cuboid of LBH of dimensions length L, breadth B, height H is L stands for length, B stands for breadth, H stands for height, whose dimensions are L, B, H. First option LB plus BH plus HL 2 times, B L square plus B square plus H square, C root of L square plus B square plus H square, D LBH. See, very important problem this is. Formula you remember, the length of the longest rod that can be exactly placed in a cuboid whose length is L, breadth is B, height is H is given by the formula C. So therefore you remember the length of the diagonal of a cuboid is equal to root of L square plus B square plus H square. This is equal to the length of the longest rod. So that's why option C is the right option. Option C is the right option. Twenty-ninth. The length of the longest rod that can be placed in a cuboid whose dimensions are 5 by 4 by 3 is in centimeters. A 25 root 2, B 20 root 2, C 5 root 2, D 10 root 2. Nikhil Sharma, are you from Sri Chaitanya College, Guntur? Who is Nikhil? I do not know. Jagadeep. So length of the longest rod that can be placed in a cuboid whose dimensions are L, B, H. L equals to 5, B equals to 4, H equals to 3. Length of the longest rod. Equal to length of the diagonal, that is square root of L square plus B square plus H square. This is also diagonal only, length of the diagonal. Okay, square root of L square. L square is 25, B square is 16, plus H square is 9. This will be root 50. Root 50 we can write square root of 25 into 2. That is 5 root 2 centimeters. So C is the right option. C is the right option. Please don't chat, private chat Mr. Chanda Jagadeep and Nikhil Dharmana. So regarding to the subject you need to discuss. Please try to concentrate. I'll give one wonderful beautiful question. You try to solve it now. If L, B and H are the dimensions of a cuboid such that L plus B plus H is equal to 12 and L square plus B square plus H square is equal to 50, then its total surface area is in centimeters. Okay, just try this question now. Later I will give the options. See what is given actually here. See, L, B, H are the dimensions of a cuboid such that sum of the dimensions is 12 and sum of the squares of the dimensions is 50. Then its total surface area we need to find out. So what is the total surface area? Total surface area TSA of the cuboid is formula 2 times LB plus BH plus HL we need to find out. See, we have wonderful formula from 9th class algebra. So 9th class real numbers or polynomials we have studied. See L plus B plus H whole square equal to, you can write L square plus B square plus H square plus 2 times of LB plus BH plus HL. So we need this value. This is nothing but total surface area. That means L plus B plus H whole square minus of L square plus B square H square gives us, this is nothing but total surface area. So this can be written like this now. So this equals to, this can be formulated as L square plus B square plus H square. So minus of L square plus B square plus H square. So both values given. This is 12. One minute, let me do the problem. LB plus H whole square, sorry, this minus this one. So this equals to 12 square minus 50. 144 minus 50. This is 494 is the answer. 94 is the answer. So this is very important question. This may ask in the examination. See, one more thing. Instead of this value also, D may be given. D means length of the diagonal is 5 root 2. This may be given. Length of the diagonal means that is root of L square plus B square plus H square. Then squaring on both sides, you get L square plus B square plus H square. Then the same total surface area, we need to use this algebraic identity formula. Yes, 94 centimeter square is the answer. In centimeter square. Yes, 94 centimeter square is the answer. Okay, tomorrow we shall do some more variety problems. Till then, goodbye. Thank you. Bye bye. See you in the morning. Actually, we have the class. I have given the schedule also. I don't have the idea. It may be by 7:20. I think so. We have the class timings tomorrow. By 7:20, we shall discuss trigonometry. In trigonometry also, we discuss some variety of problems. We discuss. Okay. I hope the 30th question is very, very important. Please keep on mind this problem. So this is application of mensuration with algebra. Algebra is connected to the this mensuration chapter. All of you enjoyed my class, I think so. I hope you enjoyed. Have you enjoyed or not? Okay. Thank you. Thank you.